Welcome to The Explainer. Floods, megadroughts, wildfires, they aren't just taking over our news feeds anymore, right? They're literally redefining our physical reality. But look, we're not here to rehash the basics. You already know the planet is warming. Today, we're going straight to the source to unpack the advanced climate models, those shared socioeconomic pathways, and the actual physics driving our future hazards. Okay, let's dive into this and figure out how we can build a real blueprint for resilience.
150. Just sit with that number for a second. In the year 2024 alone, we saw over 150 recorded major climate disasters globally. And we aren't just talking about your typical seasonal storms here. We are talking about massive events that displaced thousands of people and completely shattered economic baselines. All happening in the exact same year we officially breached that critical 1.5 degrees Celsius warming threshold.
Which brings us right to the core argument of the current scientific consensus. Natural disasters are no longer random acts of nature. Modern climate science has drawn a totally unmistakable line between human-driven climate change and the rapid, terrifying intensification of these events. The extreme weather we're seeing, it's basically the Earth's direct physical response to a fundamentally altered atmosphere. So you really have to ask yourself, are natural disasters still random acts of nature? Well, once we accept that the answer is a resounding no, it completely shifts our perspective. It moves us from this feeling of helpless anxiety straight into scientific empowerment. Think about it. If these events aren't random, they're governed by physics. And if they're governed by physics, that means they can be modeled, predicted, and ultimately outsmarted.
Section 1. The Engine of Extremes. Understanding the Physics of Global Warming. So why does a warmer planet automatically mean a more dangerous one? Well, it boils down to a super simple, undeniable mechanism. Step 1, greenhouse gases trap heat. Step 2, and honestly, this is where the extremes are really born. The warming atmosphere acts just like a giant sponge. It holds 7% more moisture for every single degree of warming. That is a massive amount of water. By step 3, this huge volume of suspended water fundamentally alters our weather patterns. It virtually guarantees more intense downpours while at the same time rapidly accelerating evaporation during droughts. It's a double-edged sword.
And the result of that volatile atmosphere? They are actively shaping the hazards we face right now, today. Global studies are showing that up to 75% of reported natural disasters today have climate and weather-related causes. Up to 75%. Now, while that remaining 25% represents standard natural variability, it highlights something absolutely crucial. Climate change acts like a massive amplifier. It energizes the baseline, turning what would normally be an ordinary weather system into a catastrophic event.
Section 2. A Catalog of Extremes. Projected hazards beyond 1.5 degrees Celsius.
As we inevitably push past that 1.5 degree goal and head toward 2 degrees or more, the hazards become profoundly localized and, frankly, severe. We're looking at a huge increase in mega droughts, specifically threatening the Mediterranean, the southwestern United States, and parts of Asia. On the flip side, that volatile, moisture-heavy air we just talked about means devastating extreme precipitation. Think about the late-season floods that recently battered Southeast Asia, all while hotter, drier baselines are literally turning global forests into tinder boxes. Let's look at how this builds over time, because warming triggers some pretty terrifying chain reactions. Right now, present day, rapid glacial retreat is creating these volatile meltwater lakes held back by really unstable ice dams. It's a disaster waiting to happen. Looking ahead to 2040, projections show critical Himalayan glaciers could potentially disappear entirely. That would starve downstream populations of absolutely vital water resources. And looking further out to 2100, well, under high-emission scenarios, 2 to 3 degrees of warming guarantees significantly elevated risks across the board, the whole shebang. Now, you might be wondering, how do scientists confidently map out these specific timelines? They use what are called shared socioeconomic pathways, or SSPs. And look, these aren't just educated guesses. They are our most robust mathematical models that actually translate human behavior and economic decisions into atmospheric consequences. They allow researchers to project enhanced tropical cyclone intensity, massive shifts in precipitation zones, and rising sea levels. And the scary part? They prove that even moderate pathways lock in some pretty substantial global changes.
Section 3. Scenarios and Vulnerability. The Cost of an Unstable Climate.
So, who and what actually bears the heaviest burden of all these projected extremes? Well, the financial cost alone is already staggering, but there's a stark, really unfair disproportion in the actual impacts.
On the human side of things, low-lying coastal regions, small island states, and impoverished inland communities are absorbing the deepest shocks, mostly due to a lack of resilient infrastructure. And ecologically, we are pushing critical, life-sustaining systems like coral reefs and boreal forests toward irreversible tipping points. We're talking about damage that won't just be severe, it'll be permanent. Section 4. The Resilience Blueprint: Scientific Solutions and Adaptation.
Now, what's really interesting here is that while the projections are definitely alarming, the scientific consensus also provides us with a rigorous two-pronged blueprint for resilience. Column 1 is mitigation. This is about rapidly reducing our greenhouse gas emissions to cap future risks. But, and this is a big but, because a certain amount of warming is already baked into our atmosphere, we desperately need column 2, adaptation. This means we have to invest heavily in nature-based solutions, deploy advanced early warning systems, and build hyper-resilient infrastructure right now. Not tomorrow, today.
So the crucial point is that we are in an absolute race against time to close what experts call the adaptation gap. Our efforts to adapt have to happen directly alongside our efforts to mitigate. The climate windows we currently have to protect our communities, they are closing rapidly. We need immediate, equitable adaptation finance to cope with the inevitable changes that have already been set in motion.
The evidence is simply undeniable at this point. Future natural disasters are going to intensify and they are going to expand. The risks are incredibly real. But, and I really want to emphasize this, they are not immutable. Strategic mitigation and adaptation can severely reduce these impacts. We have the knowledge, we have the models, and we have the solutions to build a resilient society. The only question left is, will we close the adaptation gap before our climate windows shut completely? Thank you so much for joining me for this explainer, and I really hope this deep dive leaves you informed, focused, and ready to champion resilience in your own world.